Hello, Algebra 1. Yesterday, you guys were doing the intro to 7.5 where you were learning how to factor a trinomial into two binomials. We're going to continue that today. Now, yesterday, you did kind of a guess and check method where you tried something out, you foiled it to see if it worked. If it worked, great, you were done. If it didn't work, you had to start over. Now, let me tell you that when I was in the 8th grade, that was exactly how we were taught. That was the only option you had, was guess and check. But I will say that over the many years since that occurred, there are some cool methods for how to factor trinomials. Now, there's lots of methods, but I'm not going to show you lots of methods because that can get confusing when you have about 4 different methods going on in your brain and you don't know which one to use. I'm just going to show you one. To me, this is the quickest and the easiest way to factor these problems. Now, if you're looking at example 1, you might think, well, that doesn't look very quick. That looks like a lot of steps. And right now it does look wordy, but the more you practice this particular method, the faster and easier it gets. If you still like the guess and check method, then if you're taking a quiz or a test and that's the way you want to do it, then I don't have a problem with that if you are successful with it. But as we are doing this section, I really want you to try it this way, because when you get into Algebra 2, and if I'm your teacher still by then, this is still the same way that we do it in Algebra 2. We use this method in pre-cal. It's one of those things where you, this is just the way that I teach it because it does get faster and it does get easier the more you practice it. So I would just encourage you right now, even though it may seem lengthy at the beginning, it gets easier and it does become super fast to do these problems. So let's get started. We're going to factor 2x squared plus 11x plus 5. So step number 1 says that we're going to make a sum and product chart. Let's talk about what those words mean real quick. Sum means what you get when you add 2 numbers. Product means what you get when you multiply 2 numbers. Hopefully you already knew those words. Okay, so if you look at this diagram right here, it says that what we're going to use for the sum is the coefficient of the middle term. So for this problem, this is the middle term, and our coefficient is a positive 11. So right here, beside the word sum, I'm going to put a positive 11. Then to find the product, it says you're going to multiply the coefficient and the constant to find the product. So in other words, we're going to take this positive 2, we're going to take this positive 5, product means multiply, we're going to multiply 2 times 5, and we're going to get 10. So we have a sum of 11 and a product of 10. Okay, so I always tell students we're going to start on the product side. We're going to start in that column. And so what I would do is I would encourage you to write down all of the ways that you can multiply numbers to get 10. So I could do 1 times 10. I could do 2 times 5. Don't forget, you could also multiply negatives. So you could do negative 1 times negative 10. You could do negative 2 times negative 5. Those are all the ways that we can multiply integers together to get a positive 10. Now, once you have all of this done, the goal is which pair of numbers can you add, because remember that's what sum means, can you add to get a positive 11? Well, these two I can go ahead and scratch out, because if I add 2 negatives together, I get another negative. But I can also scratch out the 2 and the 5, because if you add those together, you get a 7. We don't want a 7, we want 11. And so that's where the numbers 1 and 10 are going to work. So step 1, every time we do a sum and product chart, the goal is, can you find 2 numbers that add to equal your sum and multiply to equal your product? And that's what we did. Step number 2, we're going to take those 2 numbers, the 1 and the 10, and it says divide each number by the coefficient of the first term. So I'm going back here, I'm looking at the first term, and I'm going to divide each of those numbers by whatever that coefficient is. In our case, it's a 2. And this right here, underlined, is the most important step. If you don't do this step, you will get it wrong. It says, if possible, reduce. 1 over 2 does not reduce, but 10 over 2 reduces to 5 over 1. I cannot stress to you enough, if you don't do that step, if you do not reduce, you will get the wrong answer. So it is very important. That's why maybe put a star beside it like I did. You must reduce in order to get the right answer at the end of the problem. Now comes the easy part, y'all. So I'm going to draw my parentheses. Now, if you look at the original problem, you notice that your variables are in the front. That tells me my variables are going to be in the front. And we saw that yesterday. If your variables were in the back, that's where your variable was in the parentheses, but if they were in the front, they're in the front in the parentheses as well. So step 3 says to put in factored form as two binomials, the denominator becomes the coefficient of the first term and the numerator becomes the coefficient of the last term. So here's what that means, because I know that is very wordy. The bottom number goes in the front, the top number goes in the back. Now because that was a positive 1, I'm going to put a plus sign there. Same thing happens here. Bottom number goes in the front, top number goes in the back. Again, because that was a positive 5, I'm going to put a plus sign. That's the answer. I only have to do it one time if I follow my steps correctly to get the answer. I don't have to guess and check and maybe have to do it 3 or 4 times. Now, real quick, let's just FOIL it out to see if it actually worked. So we would start off with first, we would do 2x times 1x. Then we would do outer, so 2x times 5. Then we would do inner, 1 times 1x. And then we would do last, 1 times 5. 2x times 1x is 2x squared. 2x times 5 is 10x. 1 times 1x is 1x. 1 times 5 is 5. What's going to happen right here in the middle? They're going to turn to 11x. Is that what we started with? Absolutely. So this right here is the final answer. All right, so let's try it with number 2. Okay, so remember we said the sum comes from the middle. We have a positive 10. The product comes from the first and the last. We're going to take those two numbers, we're going to multiply them together. 3 times 3 is 9. We want to start in the product column. We could do 3 times 3, 1 times 9, negative 3 times negative 3, negative 1 times negative 9. Those are our possible choices to multiply two numbers and get 9. But now we're going to look at our choices and determine which ones add up to become a positive 10. Well, obviously not the last two, because negative numbers add up to be another negative number. And not the first one, because 3 plus 3 would be 6. But 1 plus 9 would work perfectly. So there's step 1. We have figured out the two numbers that we need. Step number 2 says to take those two numbers and divide them by what's in the front, which in our case is a 3. And then the most important part of step 2, it says reduce if possible. You cannot reduce 1/3, but you can reduce 9 over 3, and that turns into a 3 over 1. Now comes the last step, which is hopefully the easy part. Let's look at our variables. Where are they? They are in the back. So the p's will be in the back. Now remember step 3 says your bottom number goes in the front, your top number goes in the back. Because that was a positive 1, I'm going to put a plus sign there. Same thing over here. Your bottom number goes in the front, your top number goes in the back, and because that was a positive 3, I'm going to put a plus sign. Let's FOIL it real quick just to see what happens. So if we did first, we would do 3 times 3, which is 3. Then we're going to do outer. 3 times 3p is 9p. Then we're going to do inner. 1p times 1 is 1p. And then we're going to do last. 1p times 3p is 3p squared. What happens when you combine the two in the middle? You get 10p. So we have all of the terms that we need, and our answer is already done for number 2. Let me see if I can get more lead in my pencil. Come on. Oh no. It is donezo. Okay, let me see if I can find a pencil real quick, y'all. Sorry about that. Pretty sure good pencils might be downstairs, and I'm not about to walk downstairs. So let's just do the old-fashioned pencil here. Oh, I'm so sad I ran out of lead. Whoops. Okay. Example 3. Here we go. Sum comes from the middle, so -7. Product comes from the first and the last. We're going to multiply those together. 5 times 2 is 10. All right, we're going to start on the product side. How can you multiply numbers to get 10? You could do 1 times 10. You could do 2 times 5. You could do -1 times -10. You could do -2 times -5. Lots of options, right? Which of those would add to give us -7? The last one would. None of the other ones work. So we have -2 and -5. We're going to put them both over our leading coefficient. So we want to put them both over 5. And then we want to see if we can reduce. Well, -2/5 does not reduce, but -5/5 does. That turns into -1/1. Okay, so we've got our two numbers. We divided by our leading coefficient, and we reduced, and now we're at step number 3. Look at your variables. This one's a little bit different because you have variables in the front and in the back, which means we're going to have variables in the front and in the back. Which variable is in the front? M. Which variable is in the back? N. Now let's use those fractions. Remember, your denominator goes in the front, your numerator goes in the back. That also included that minus sign already. All right, same thing over here. Your denominator goes in the front, your numerator goes in the back. Let's see what happens if we were to FOIL that out. So first, 5m times 1m is 5m squared. Then let's do outer. 5m times -1n is -5mn. Then let's do, wait, we just did, I don't know if I said outer or inner. That was outer. I don't know what I said. Inner, -2n times 1m is -2mn. And then last, -2n times -1n is +2n squared. We have the first term, we have the last term, and if you combine these two, we have the middle term. So we know without a doubt that that answer is correct. Now as we look at number 4, I will tell you that there is going to be an extra step involved, because I want you to look at what we have. We have 8k squared minus 16k plus 6. We always, always, always need to be on the lookout for a GCF. So let's look at those. Do they all have a variable? No. But is there a number that can divide into all of those numbers evenly? Yeah, 2. All of those numbers are even. So let's take it out. Remember, this is doing the distributive property backwards. So we're going to divide everything by 2. So 8k squared divided by 2 is 4k squared. -16k divided by 2 is -8k. And +6 divided by 2 is +3. This step is so important. Please put a star beside this. So we always, always, always need to look for a GCF. That is the most important step. Now, when you go to do your sum and product chart, you completely ignore your GCF. You are only focusing on the trinomial within the parentheses. So our sum, remember that comes from the middle term, so we're going to have a -8. Our product comes from the first term and the last term. We're going to multiply 4 times 3, and we're going to get 12. All right, let's talk about 12. You could do 1 times 12, 2 times 6, 3 times 4. You could also do -1 and -12, -2 and -6, -3 and -4. You have a lot of options for that +12. But of those 6 options, which one will allow us to add to get a -8? That one right there is the only one that works. So we need a -2 and a -6. Now step number 2 says we're going to divide them both by the leading coefficient. Remember, we're completely ignoring the 2 that we took out. That is not the leading coefficient. We are only looking at our trinomial, and our leading coefficient is 4. Now both of these get to reduce because -2/4 reduces to -1/2, and -6/4 reduces to -3/2. Again, that step is so important. If you forget that step, your answer will not be correct at the end of the problem. So now I'm going to look at the variables. Where are they? They're in the front. So the k's are going to go in the front. So remember, the denominator goes in the front, the numerator goes in the back. Same thing here, the denominator goes in the front, the numerator goes in the back. Now with this type of problem, because we took out a GCF, you have to keep it with your answer. Don't get rid of it. Don't forget it. You leave it alone for a little while, and then you make sure it's a part of your answer. So let's check and see if this is accurate. I'm going to start by ignoring this for a moment, and I'm going to work on foiling those two binomials. So first, 2k times 2k is 4k squared. Outer, 2k times -3 is -6k. Inner, -1 times 2k is -2k. And last, -1 times -3 is +3. So if I combine like terms, I get -8k in the middle. And here's where I'm now going to focus on bringing that GCF back in, because I'm going to take it and I'm going to distribute it to see if we get what we had in the original problem. So 2 times 4k squared is 8k squared. 2 times -8k is -16k. And 2 times 3 is 6. And now this problem looks exactly as it did at the beginning. And so this is our final answer. All right, so what I would like for you to do, I'm going to stop the video. I want you to try the next 3 and then check out the next video and you can see how I will work those out. But try them on your own. Try working with the sum and product chart. Please, please, please don't forget to first look for a GCF. Not every problem will always have a GCF, but if you don't look for a GCF, your answer will not be correct at the end. So look for a GCF, make a sum and product chart, then take the two numbers that you get, divide them by the leading coefficient, reduce, 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 and then change it into the binomials in parentheses. And I will meet with you in a moment in the next video.